So, hello students, welcome back to Fun Scholar Academy. Today we will be studying States of Matter lecture number 2. In the previous lesson, you have learned about what is matter, what are the different types of matter, what are the properties of different types of matter along with their example. So, today we will be studying that how to change one state of matter to another state of matter. For that, the perfect example and the easiest example that we can see is water. Water is such state of matter that exists in three forms already, like solid, liquid, and gas. How, ma'am? You have seen ice cubes, right? That is what? Solid form of water. Liquid is water itself. And gas is steam or water vapor. Right? So, water is the only substance that can be changed into different form. So, let us now understand how water changes from one form to another. You see this picture? Liquid, water, gas, then again solid, then again liquid, again gas. So, this cycle goes on in our nature itself. How? When water is in solid state, we write it as ice or snow. Okay, now we will apply heat to this ice. You know, in the summer, the polar region, the ice melts and form what? Water. So, if you apply heat, it will come into liquid state, which is water itself. Now, further if we heat it, what will happen? It will change into gaseous state, that is vapor. Now, how do you see vapor in nature? During summer times, you do observe that the ponds, the lakes, the streams, even the rivers, the amount of water decreases with time. You know how? Because water, due to the presence of extreme heat, they get vaporized and converts into gas, that is water vapor. Okay. Now, again, if you cool down the vapor, it will again be converted to liquid state. Further, if you cool down the water, then it will again form solid state, that is ice. So, the states of matter are interconvertible. The state of matter can be changed by changing their temperature or pressure. Okay, I took the example of water because it is the best example in which three forms of state can be easily seen. Okay. Now, first, what is melting? You can see ice cube over here. Okay. Or you can take a ice cube out of the refrigerator and keep it in a cup or a plate. After some time, what happens? See, the water starts melting into, so the ice cube melting. Then what happens? These are droplets of water, right? Okay. So the process by which solid things change into liquid state of matter is known as melting. Okay, even when you light a wax candle, have you ever observed that the upper portion turns liquid and slowly the size of the candle reduces? You know why? Because due to the presence of heat, the solid candle starts melting and it takes the fuel so that it can burn. So, melting can be seen in ice cube, then in candle, wax, etc. So what you have to remember from this? It is a process by which solid substance changes into liquid substance. It is known as melting. Okay, students? Okay. Now, what is boiling? See, when you lit gas, the water forms bubbles, right? And after some time you can see vapors going up and the level of water reduces with time, right? If at present it is at this level, after 1 hour it will be at this level until whole water gets vaporized. So what is boiling? This state is liquid state, obviously. And when the gas is formed, it forms gaseous state. So what is boiling? Boiling is nothing but change of state of matter from liquid to gas. From liquid to gas. Understood? Right? Okay. Now evaporation. So what is evaporation? Just now I have told you that during summer days when the sun is there and it is very hot. Now it is summer, so it is very hot outside. What happens? The ponds, lakes, everything dries up. Do they dry up naturally or do we heat them? Obviously, they dry up naturally. So, the natural process by which a liquid substance is changed into gaseous substance, that process is known as evaporation. Okay, the phenomena of change of liquid into vapor state at any temperature below its boiling point is known as evaporation. The first point you must remember that it is a natural process. Right? Second point, it occurs at normal temperature or in any temperature of the surrounding environment. Like if you go to mountains, automatically evaporation will occur. If you go to sea area, automatically evaporation will occur. Even in your house, if you keep this bottle open and leave it for 10 days or 7 days, you will come and see that the level of the water decreases gradually with time. Okay, so evaporation is a process which occurs worldwide but naturally. At any temperature, you don't need to put artificial heat to it. This is the basic difference between evaporation and boiling, which we are going to learn in the next slide. See, first point, evaporation occurs only on the surface of the liquid. See, evaporation always occurs from the surface of any liquid. But boiling, when you are putting heat, this is the symbol of heat, okay? This is heat. When you are giving heat, see the molecules of the water, they are moving in random direction, and if boiling is taking throughout the liquid, right? So now if I ask you, there is a circular phase vessel. There is a bottle and there is a small egg. Now I am putting water. So can you tell me, after suppose 2 days, this is one, this is two, this is three. In which of these three bottles the level of water will decrease in rapid, or evaporation will occur at rapid mode? Can you tell me? Just guess. Okay. So for evaporation to occur, I have already told you that evaporation occurs from surface. Okay, not throughout the liquid. So a container having a greater surface, the chance of evaporation will be more. So among these three, where do you see the greater surface of the container? Obviously in the container one, right? So evaporation after 2 days, you can see container one will have maximum evaporation. Understood? So where I was, yes. So evaporation is a natural process, whereas boiling is a artificial process. Evaporation occurs only from the surface of the liquid, but boiling occurs throughout the liquid. The greater surface area, the rate of evaporation is higher. Okay, very good. Now, what is condensation? Condensation, first you come to the picture. See, there are tiny droplets of water are being formed on this bottle, on this glass. You know how it is being formed? From refrigerator, you take out a bottle. Okay, it is filled with cold water. And after some time, see droplets of water are being formed on the outer surface of the bottle. Okay, now you might have been thinking that the water from inside is coming out and forming these droplets. No, this is wrong. What is actually happening, you know? It is cold in nature. The outside temperature is cold, right? In the air, there is present hot air. Okay, this hot air comes in contact with this cold water bottle, and condensation is such process by which gas changes into liquid state. So what happens? The water inside the bottle do not come out, but water vapor is present all around your surrounding, which comes in contact with the cold surface and is being condensed there, and they form water on this outer surface. So understood now that why the cold drink bottle, after some times you find water outside the bottle, the water does not come out. It is the water vapor which is being deposited over there due to the difference of temperature. So what is condensation? Condensation is such a process by which gaseous state of matter is changed into what? Nothing but liquid state. Gas into liquid, that is condensation. Okay, now freezing. You all know what is freezing, right? Water into ice cubes. This is what? Solid. So what is freezing? Freezing is nothing but by which liquid state of matter changes into solid state. Liquid state of matter changes into solid state, that is known as what? Freezing. Okay, now there is a video time.
We have seen a few methods of separating solid particles from water and now are well versed with these techniques. These methods were sedimentation, evaporation is. It is simply a process in which water is converted into steam or water vapor. So changing the state of water from liquid to gaseous state is called evaporation. If you keep water in a vessel and heat it for a prolonged time, then all the water gets converted to steam. This is how evaporation. How does evaporation work? This, let's understand this is the most complicated. We know that seawater contains various salts dissolved in it. We also know the fact that a lot of heat from the sunlight is responsible for causing evaporation of water from the water bodies present on the Earth's surface. So, can we combine these two points to get a single solution? Yes, we can. Seawater is collected in large panels near the sea. When water from these panels evaporates, it leaves behind the salts dissolved in it. The salts can then be collected, purified, and processed further to obtain the common salts that we use daily. This is how evaporation of seawater helps us obtain salts that can be processed further to gain the daily used common salt. So evaporation is very useful in separation of substances and it's exactly opposite of condensation. What is condensation, by the way? As I just said, condensation is the opposite process of evaporation, which means converting the gaseous form of any substance into a liquid state. So in case of steam, it's converted to its liquid form, water. But how can condensation be useful in separating substances? It is used in combination with other methods for separation. Does that mean there are multiple ways of separating substances?
Okay, so you needed up to this only in this video. Now back to your slide. So now we will first do an experiment and then we will proceed in the slide. Okay. So you see there is an empty glass. I am just putting some water in it. Okay. Now what I am doing, I am taking a spoon of sugar and I am putting this inside. Now if I stir it, what will happen after some time? Will the sugar dissolve in the water? Yes, they will. I think you all have done this at your home or you have seen your mother or someone else doing this. Okay? For your further understanding, I am making it a bit more interesting. See, this is ruabza. You do eat, drink this. Now I am putting a bit of ruabza in it. Okay, I am mixing it. The water is turning pinkish, right? And the sugar is melting with time. If I stir it more, it will completely get dissolved in it. So, and what it is happening? It is called ruabza sharbat, right? Or a drink for the summer season. So, do you know what did I just do scientifically? Do you want to know it? Let's find out. I'm keeping this aside. See, the sugar particles got completely dissolved or completely mixed in the water. And if I add a bit more ruabza, see, the color will turn more red. See, see, right? Looks yummy. Yeah, it's good. So, this thing scientifically is known as solution, though in common language, you know, it is known as ruabza or sharbat or cold drinks, anything. So, this is the water part. This is the water I have taken. This water is known as solvent. The part which is taken in larger amount is scientifically known as solvent. And then I took this small sugar, also syrup or ruabza, whatever you want you can say. So I have taken this in smaller amount. This is known as solute. And after mixing this, the sharbat you got, this is scientifically known as solution. Okay. So what is a solution? Solution is formed by combination of solvent and solute. Solvent plus solute equal to what? Solution. Solvent is greater amount in which solute dissolved, and solute is the smaller quantity of material that got dissolved in the solvent, and they both formed what? They both formed solution. Okay, now let us read. A solution is a homogeneous. Homogeneous means something when you are mixing two different substances or three different substances, they are forming a clear water or transparent solution. This is homogeneous. But if I add, suppose this spoon I am keeping inside the water. Is it getting dissolved? No, it doesn't. So this will form what? Heterogeneous solution. If a substance get dissolved in water or in solvent, then it is known as homogeneous. And if it doesn't, it is known as what? Heterogeneous. You please write these points. These are very important for your upcoming classes also. So a solution is a homogeneous mixture of two or more substances where one substance is the solute that dissolves completely in another substance, the solvent. I think now for the whole life you will remember what is solute, what is solvent and what is solution. And one extra information is that you please write it down that water is known as universal solvent. Water is known as universal solvent. Okay? Now some examples of solution. Sugar in water, just now I have shown you this. Sugar in water, sugar gets completely dissolved in water, which I have already shown you. Salt in water, do this at your home and find out whether it mixes or not. It will. Lemon juice, this also you have seen at your home and forms what? Lemonade, which is summer drink. Okay? Okay. Another thing, air. You breathe in oxygen, you give out carbon dioxide. So in this air, you know both oxygen and carbon dioxide are present. Apart from this, gases like nitrogen, hydrogen, sulfur dioxide, carbon monoxide, etc. are present in the air. So, air is also a solution of what? Different kinds of gases. And also it is known as mixture. Air is a mixture of different gases like hydrogen, oxygen, nitrogen, sulfur dioxide, carbon monoxide, carbon dioxide, oxygen, etc. So we can say air is universal again what solution of gases. See, parts of solution. I have already told you the greater part, that is water, is solvent. The smaller part is solute, and what is formed after we mix both? They form solution. So what are the parts? Solute and solvent. Okay. This is the last thing I'll show you today, and next we will continue in the lecture 3. See, the small simulation is there, a homogeneous mixture of two or more substances. They are giving salt in the water, and see it is mixing and forming salt solution. Right? But this is only the thing I have taught you today. Again, if you add vinegar to the water, it will form acetic acid solution. Okay? Then, bus, this one is done for the day. So, today up to this much. Thank you students. See you in the next class. And learn till then.